session, and today we are working on another problem from LeetCode. It is about binary tree paths. Given the root of a binary tree, return all root to leaf paths in any order. A leaf is a node with no children. So the question is very clear here. First of all, the important thing is that you should know leaf, and leaf in the context of this binary tree is any node that has no children. For example, in this binary tree we have two leaves. One is the number 3 and the other one is number 5, because they do not have any other children. So we have to find the roots from root, which is number 1, to every leaf. For example, 1, 2, 5, 1, 3. In case we had another node here, for example, 1, 2, let's say 4 here. So we should be able to find 1, 2, 4, and then 1, 2, 5, and then 1, 2, 1, 3. So from the root node to all the leaf nodes, and finally return them as an array like this. For example, here 1, 2, 5, 1, 2, 5, and comma 1, 3, 1, 3. So we have to find the paths from root to leaf, as many leaf it has, like this. Finally return them as a result, as an array in the result. So it is very clear that we need to have an array of result or paths that we keep all the result there and finally return that. So I created that empty array here. So now when we start searching or start looking from root to every leaf, we already know how to traverse a tree. We studied in our previous lessons about DFS, deep first search, and BFS, breadth first search. You know that BFS or breadth first search was exploring all the nodes level by level. For example, first this level, and then this level. But DFS was going as deep as possible. And in this example, DFS is much easier to use for this, because every time we need to go as deep as possible. That means we have to reach the leaf node. So in this example, I will use the DFS method and solve this problem. So first we need to have a result array in order to, whenever we start, for example, traversing from the root node and we go as deep as possible, so we have to keep these paths, we have to keep the track of this and finally put them in the result. So const result equals empty set. So let's say that we use the DFS so I think I can define DFS here as well. Constant DFS equals, so every time we need to pass an array, which is the first time we pass the root node, and instead of root, let's say node, the general meaning, because we use this DFS method, we call this DFS method recursively for each of these node. So for that reason, for example, when we are here and we call DFS, so it is although it is root to the below nodes, but there is not the main root. So for that reason, if we say node, that gives a better meaning. We have to pass the node, and we have to keep track of paths between all the nodes that you are traversing them. So we have to keep the track of the paths as well. So okay, now first check if node doesn't have a value. Automatically do not go ahead and return. If node doesn't have a value, or it is undefined or null, automatically return. You don't need to go any further. So otherwise, for example, let's suppose we have called this on this node. At this point, the one is like this, so the path should get the value of number 1 here. So let me add number 1 here in the path, and here we can say that, well, path plus equals a node dot value, it is the structure of our node, so I got the value from this. Okay, node dot value. Now we have the number 1 in the path. So next time, after number 1, we have to add this symbol sign, and then we go to node 2. So before going to node 2, first we check if it is the leaf node or not, because if it is the leaf node, then there is no need to go to the next node. That doesn't make sense. That doesn't give a meaning when you are at the leaf node. So there is no next or there is no child node. For that reason, check this node first. Say that if this node doesn't have any left or right child, if this node doesn't have a left child, and if this node doesn't have a right child, that means it is a leaf node. So if it is a leaf node, we have to put the path in the result and return result dot push path and return. But if this condition does not meet, that means it is not the leaf node. For example, right now we are here, it is not a leaf node, so we can go to the next node. However, before going to the next node, we have to add this sign to the path also, this sign. So here we can say path plus equal, okay, this sign, okay, this sign, like this. Okay, now we can recursively call this DFS method on left and right children. DFS node dot left, pass the path also, and DFS node dot right and pass the path also. So this way it checks every node and keep the track of this path from root to the leaf and push them in the result, and finally we return only the result. However, let's go a little further that how it continues processing. For example, so when we are at this point, so we added this, and now we call node.left. Node.left means number 2. We pass this time number 2 to the DFS function. So this time, and the path has this value, number 1, and this sign, because we added a number 1 here, node.value, and this sign here. Now the path has this value. So at this time that we call node.left, that means this node, node 2, and path means this one. Let me highlight this. At this point, path means this one, and node.left means this one. So when we call this function recursively, so again, first it checks if this node has a value or not. Of course it has a value. So again, here on the path that we passed here, it says that path plus node.value. Again, it gets the value of number 2. So we have the number 2 here, and then it checks, is the number 2 a leaf node or not? So we see it is not a leaf node. If it is not a leaf node, so it goes ahead at this time at this sign, and then call this dfs.node.left. So at this time when it gets called, So automatically you see that at the beginning of this DFS we said if node.left is called, and here it checks if node doesn't have a value. If it is null, automatically returns. For example, at this point when we call node.left, there is no node.left child, so it checks that and automatically return that and comes to the node.right. So at this point we call node.right and we pass also the path. Also it is the path now at this point, so it is the value at this point. And now in the path, first we add the value. For example, node path equals node.value, it is 5, and here it checks, does it have a left or right child? No, it doesn't have any right or left child. That means it is the leaf node. That means we got one path from 1 to the leaf node. So we push this path into the array, into the result array, and return. So now it starts backtracking. When we were here, it backtracks at number 2. Number 2 both left and right is checked, and then it backtracks to number 1, and here the left is already checked, so it is calling only on the right side, the right path. And the path begins again. Similarly, keeps track of the path from 1 to 3 like this, and we push that also to the array result, and finally we return the result. Okay, so first call the function dfs. At this point we pass the root node and an empty string just for the storing the path that we call path here. So return the result. Okay, okay, here is a spelling mistake. Const dfs. Okay, it passed both test cases, and it was very easy. I hope you understood how it works. In case any part is unclear or you have any questions, just comment them below, and I will come to your comments. I will read them and I will explain how it works. Until the next problem that we solve from LeetCode, have a nice time, everyone.